In this video, we're going to work on the ALEKS problem called describing peptides with three-letter codes. This problem is going to give us the structure of a molecule. It's going to ask us to describe what type of molecule it is, and if it's a peptide, it wants us to describe that peptide using the three-letter codes of the individual amino acids in the molecule. So to help you solve this problem, first of all, you're going to want to pull up ALEKS's table of amino acids that's in ALEKS's data table area, and I've got a PDF of that table of amino acids over here to make it a little easier for us to solve the problem. I looked at quite a few different variations of this problem, and one thing that I noticed is that the problem never gave me a monosaccharide or a polysaccharide. And I don't think that either of those are anything that you're going to encounter, because this problem is asking us to describe peptides, not sugars, which is what those were. I also didn't see any version of the problem that asked or that provided me with an amino acid, although I do think that that's a possibility. Every problem that I looked at, I was either given the structure of a peptide or I was given the structure of something random that was not a peptide, also not a monosaccharide or a polysaccharide. So the first thing that you're going to want to do is evaluate this structure to determine whether or not it's a peptide. And to do that, you're looking for a general pattern in the backbone of the molecule. This is the part right here that I would call the backbone. In a peptide, you're going to have a nitrogen, carbon, carbon-oxygen double bond, nitrogen, carbon, carbon-oxygen double bond, nitrogen, carbon, carbon-oxygen double bond, nitrogen, carbon. There is a carbon-oxygen double bond over here. It's just kind of hidden in that condensed notation. You have to have this very specific pattern in order to be a peptide. Any variation on the pattern makes it not a peptide. So if you've got like an extra oxygen squeezed in there somewhere or an extra carbon in there somewhere, it is not a peptide. You're going to end up saying none of the above. This particular molecule, because it is following that pattern, it is a peptide. So I'm going to mark that. Now, one thing I do want to point out is that most of the time in this pattern, nitrogen, carbon, carbon-oxygen double bond, nitrogen, carbon, carbon-oxygen double bond. Most of the time in this pattern, the nitrogen, carbon is a CH, nitrogen, where is it again? Nitrogen, carbon is a CH, nitrogen, carbon is a CH. Right here kind of seems a little bit like it breaks that pattern. It does not actually break the pattern. ALEKS is kind of writing it in notation that's maybe a little bit difficult to interpret. But if I wrote one of those hydrogens sticking in the down position instead of CH2, then we're now following the pattern. A CH, C double bond O, NH, CH, C double bond, NH, CH, C double bond oxygen. Okay, if the molecule was an amino acid, which this one is not, it would just have one unit, just one unit. It wouldn't have anything else attached. It would just be a nitrogen, carbon, hydrogen, carbon, oxygen double bond. It's going to have an extra oxygen on the side. If it's just an amino acid, in fact, it's just going to be one of these guys over here. Structure is going to look exactly like one of these. If we have a peptide, and only if we have a peptide, then we're going to write the description of the peptide using the three-letter codes. Those are going to be the three-letter codes for the individual amino acids that make up the peptide. So it's going to be helpful for us to visually kind of separate those amino acids from each other. Each unit, nitrogen, carbon, carbon-oxygen double bond, nitrogen, carbon, carbon-oxygen double bond, nitrogen, carbon, carbon-oxygen double bond, nitrogen, carbon, carbon-oxygen double bond. Each unit represents an individual amino acid, and the three-letter abbreviation for the amino acid is based on the structure of whatever is hanging down off of that center carbon. We just need to go find them. Look at this guy right here is right here. That's valine, and its three-letter abbreviation is VAL. Let's see what else we can find. Oh, here we have alanine, that is ALA. And this guy, glycine, that is GLY. Remember that I kind of modified the notation a little bit. Now it is exactly the same as what we have in ALEKS's data table. And our first amino acid is serine, SER. We're going to write the three-letter codes from left to right in this order. You're going to separate each three-letter code with a hyphen or a dash, and you're going to make sure that you capitalize the first letter of each one of the three-letter codes and only the first letter.